What if everything you are, your thoughts, memories, identity, and even your sense of free will, is simply the result of neurons firing in the brain? This leads us to a profound question. If the brain is just a vast network of synapses exchanging electrochemical signals, then who or what is listening to the neurons? This is the paradox of the synaptic self illusion. At first glance, neuroscience provides a clear physical model of the mind. The human brain contains about 86 billion neurons, each connected to thousands of others through synapses. These cells communicate using electrical impulses and neurotransmitters. Modern brain imaging can even show which regions are active when you think, feel, or remember. From this perspective, the self is an emergent product of biological computation. But here is the philosophical twist. If neurons generate the mind, then who or what is observing this activity? When you become aware of your thoughts, when you reflect on your choices, or remember your childhood, what part of you is doing the observing? Let us pause here and ask, if your brain is simply processing input and producing output like a machine, is there any you outside the machinery? Some neuroscientists argue there is not. According to this view, consciousness is not a separate observer, but an illusion, a trick created by the brain to unify the experience of many subsystems. Your sense of I is just a narrative generated by the default mode network, a set of brain regions involved in self-referential thought. This would mean the self is a convenient fiction, useful for survival, but not fundamentally real. Others disagree. They point out that subjective experience, the feeling of being you, is not easily reduced to neural activity. This problem is called the hard problem of consciousness. Why does a particular brain state feel like anger or joy or self-awareness? A computer can process information, but it does not seem to experience anything. So why should your brain? Some propose that consciousness might be a fundamental feature of the universe, not something the brain creates, but something it taps into. This leads to ideas like panpsychism, that all matter has some form of consciousness, or integrated information theory, which suggests that certain kinds of information processing systems generate awareness based on their complexity and interconnection. Let us return to the question, who is listening to your neurons? One possibility is that there is no listener, only a loop. The brain models itself and labels that model me. In this view, the self is like a character in a novel written by the brain, constantly revised, updated, and believed. But another possibility is that the brain is more like a receiver, and consciousness is the signal, not something made by neurons, but channeled through them, like a radio. Can science resolve this? Neuroscience continues to explore how brain activity maps onto thought and behavior. Studies in split brain patients, anesthesia, and brain damage show that identity can fragment or vanish when specific areas are altered, but none of these studies explain why there is a first-person perspective in the first place. In the end, the synaptic self illusion forces us to confront a mystery that is both scientific and deeply personal. Is the mind just the brain, or is there something more? Would you like to explore how this idea compares to Eastern philosophies of non-self or modern AI theories of consciousness? Neurons in the brain communicate through electrochemical signals transmitted across synapses, forming complex neural networks. These networks encode sensory input, memory, emotion, and cognition through dynamic patterns of activity. The synaptic self theory posits that our sense of identity arises from these patterns, shaped by genetics and experience. Every thought, decision, or memory corresponds to specific neural circuits firing. But this mechanistic account raises the paradox. If you are your neurons, who or what is observing their activity? When you reflect on your own thinking, like analyzing your fears, your brain is simultaneously the actor and the observer. It's like a camera trying to photograph itself. Something seems to be missing in the feedback loop. The intuitive feeling of a self sitting behind the scenes and watching mental processes is known as the homunculus fallacy. Neuroscience disproves the idea of a central observer in the brain. There is no one neuron or region that contains you. Instead, consciousness appears to emerge from distributed interactions across brain regions like the default mode network, prefrontal cortex, and insula. The illusion of unity is a cognitive construct, a result of brain mechanisms creating a coherent narrative from fragmentary signals. However, this illusion is so strong that it feels undeniable. Split brain patients can act as two independent agents, yet each half believes it is the unified self. It's like a puppet made of strings, believing it is the puppeteer. Its cohesion is a product of coordination, not control. The self may be an emergent phenomenon, a higher order pattern that arises when enough neural complexity is reached. In this view, just as a swarm of bees has collective behavior with no central leader, the brain produces the sense of I through synchronized recursive processing. These self-referential loops involve memory, prediction, and internal modeling of the body and environment. As neural circuits model not just the world, but themselves within the world, consciousness might emerge. This theory supports a self that is real but constructed. Functional MRI shows self-referential thought activates a network rather than a single spot in the brain. The self is like a whirlpool in a river. It seems stable, but it is just the dynamic interaction of flowing water. Mirror neurons, discovered in primates, activate both when performing an action and when observing it. They provide a neural basis for empathy, imitation, and possibly self-awareness. By simulating the behavior of others, the brain constructs models that may also be turned inward. This introspective modeling allows us to watch our own thoughts, decisions, and feelings. Some scientists argue that consciousness evolved from this recursive mirroring of one's own mind. You flinch when you see someone else in pain because your mirror neurons simulate their experience. It's like watching yourself in a mirror, but the mirror is inside your head, reflecting not your face, but your mind. Despite knowing the locations and mechanisms of many neural processes, scientists still cannot explain how these separate signals become unified into a singular conscious experience. Visual, auditory, and emotional inputs are processed in different brain areas, yet we perceive them as a seamless moment. This binding problem is central to the mystery of the self. It implies that no single neural process explains consciousness. Only the integration does. This integrated whole gives rise to a continuous subjective I. When listening to music, your brain fuses sound, memory, emotion, and expectation into one unified experience. It's like a symphony composed of many instruments. The music exists only when all are playing together. Philosophers like Daniel Dennett argue that consciousness is a narrative illusion. The brain tells itself a coherent story using distributed modules. In contrast, David Chalmers sees the subjective experience as the hard problem, likely requiring new physics or principles to explain. Thomas Nagel questioned what it's like to be a bat, illustrating that subjectivity resists objective reduction. These views reflect the divide. Is the self a clever illusion or a true phenomenon beyond current neuroscience? The lack of consensus shows how elusive the listener behind the neurons remains. Dennett's multiple draft model suggests that many parallel stories are running in the brain, but only one becomes the conscious self. It's like many scripts being written at once, but only one gets performed on the stage of awareness. Studies on mindfulness and deep meditation show that the sense of self can be altered or even vanish, suggesting it is not fundamental but constructed. Long-term meditators report states of pure awareness without an I at the center. Brain scans show reduced activity in self-referential regions and increased integration across networks. These experiences support the idea that the self is plastic and contextual, not fixed or intrinsic. The brain can silence the illusion of the observer when its narrative functions are quieted. During deep meditative states, practitioners often describe a feeling of unity with everything, without ego boundaries. It's like turning off the narrator in a movie. You still see the scenes, but without commentary or identity. Neural firing is not deterministic. It is subject to noise, delays, and feedback. The sense of free will and authorship may come after decisions are already made subconsciously. Experiments by Libet and others show that brain activity predicting actions precedes conscious intent by hundreds of milliseconds. If the self emerges after the fact, then it may be a narrative constructed to explain actions, not the true origin of them. Thus, the listener might be more of a post hoc commentator than a decision maker. In Libet's experiments, subjects' brains initiated actions before they reported deciding to act. It's like a sports commentator narrating a play after it's already happened, adding meaning but not causing it. The idea that you are listening to your neurons may itself be a linguistic illusion. There is no ghost in the machine, no central observer, but rather a distributed system that simulates observation and control. The brain creates a model of the self, and that model includes the illusion of being separate from the processes that generated it. From this perspective, you are the neurons and the listener, simultaneously and indistinguishably. It may not be satisfying, but it is a deeply coherent view from modern neurosciences. Conscious thought and self awareness dissolve in anesthesia or deep sleep, yet the brain remains active. It's like a flame thinking it is separate from the fire, forgetting that it's only a pattern within the same energy.